J-HAT 塾
The setup of the problem is like this illustration here. We have a parabola and there are points A and B where the parabola intersects the x-axis. There's also a point C up here. And we are given the points A, B, and C in coordinates. The coordinates are as follows. A is 1, 0, B is 3, 0, and C is 4, 3. And we are told that the parabola has the following equation, y equals ax squared plus bx plus c. Now, the first problem is, what are the values of A, B, and C? Now, when we find those values, we are ready to answer the second question, which is, what is the equation of the line that passes through A and C? So here we drew it. That's the dashed line, and we will call this L. The next problem is to find the equation of the line perpendicular to L and passes through B. So it's this line, the dotted line here, and we're going to call that M. And finally, we want to find the area of this triangle that is bounded by the x-axis, the line L, and the line M. First, we're going to find the values of A, B, and C. Notice that we have three unknowns here, so we need three equations. We get the three equations by substituting these coordinates for A into this given equation, then substituting the coordinates for B into the equation, and do the same for the coordinates of C. So if we substitute, for example, 1, 0 into here, so the x is here will be 1 and the y is 0, what we get is, if we replace this x with 1, we replace this x here with 1, we get 1 plus, or rather a plus b plus c equals, here we replace y with 0, so that's going to be our first equation, 0 equals a plus b plus c. Also, if we try to use equation 118, which is, or rather, this is the point B, that's 3, 0. So we do the same thing, replace x with 3's, the x's with 3's, and the y with 0's. So we're going to get this equation, 0 equals 9a plus 3b plus c. And finally, we do the same thing for this point that we're given. We replace the x's with 4. We get 16 here, we get 4 here, and replace y with 3. And so we get the following, 3 equals 16a plus 4b plus c. We have three equations and three unknowns. We are ready to solve this system of equations. Now you notice that C, we have C here, and C here. So it's very easy to eliminate C's, the C's from these equations. So what I do here is, first we subtract this equation minus this equation. You get 0 minus 0, you still get 0 here. We get 9a minus a, you get 8a. 3b minus b, you get 2b. C minus c is just 0, so you get rid of c. Now you have this equation. Now you notice that it's divisible by 2, so we divide everything by 2. We get 0 on this side. We get 4a plus b on this side. So this is our new equation. That is from 120 and 121. Now we do the same for equations 121 and 122. 3 minus 0 is 3. 16 minus 9 is 7a. 4b minus 3b, you get b, and c minus c, that's 0. So we get eliminate c. And now we are left with this equation, 3 equals 7a plus b. Now, we notice that this one and this one, we can actually use them to eliminate b. Again, we just do the good old subtraction. 3 minus 0 is 3. 7a minus 4b is 3a, and b minus b equals 0. And so we're left with the following. We're left with 3 equals 3a, which means that a equals 1. Now that we have our value for a, we can use this value of a and substitute that a in either of these two that we got, 123 or 124, I'll choose 123 because the numbers are smaller. So I'm going to replace A with 1. So I get 0 equals 4 times 1 plus B. And that means B equals -4, right? Now I have A, I have B. I can now use these two values, substitute them in any of the three original equations that we had. I can use any of these three, but I'm going to choose the first one because the numbers here are smaller. So I'm going to choose this one. So I'm going to have 0 equals 1 minus 4 plus C. And what we're left with is, so that's this one. We see that C equals 3. So now we've solved the first problem, which is asking us for the values of A, B, and C. So we now have the values for A, B, and C. The next problem is we want to get the equation of this line L, okay? This line L passes through A and C. To do that, we use the 2-point form because we have the points A and C, so we can just use that. Those are points. And what we do here, for example, is this. On the left side of the equation, you get y divided by y minus some y divided by x minus some x. Now here, the y here must be must be a y of some point through which the line passes. So the only condition is that the y here and the x here, they must form one coordinate. So in this case, we can choose A or C because we know that this line L passes through A and C. So you can choose any, A or C. So here I'm just going to choose A because the numbers are smaller. So here's going to be the y for A, that's 0. This is going to be the y for, or the x for A, that's 1, okay? On the left side, or sorry, on the right side, you have to have 2 points. So first numbers should be from one of the points, and the second numbers should be from the other point. Now I'm just going to use A as the second number again because they are smaller, and so when I subtract, I won't get negative numbers. And the only other point that we know is point C. So that goes here. This is the y. On top is the y for C, and below is the x for C. And so that's what we have there. And so when you subtract those, the numerator becomes 3, the denominator becomes 3, and that quotient is 1. And so we get this. And now we are left with y over x minus 1 equals 1. If you move the x minus 1 here to the other side, this is what we get. This is the equation of line L. Now we need the equation for the line that is perpendicular to L and passes through B. Now, if the line is perpendicular to L, what that means is that its slope must be the negative reciprocal of the slope of L. Okay, negative reciprocal. We know that the line for L is this one. What is its slope? Its slope is 1. Okay, that's the number beside the x here. Now, if we want the negative reciprocal of that, we just get the reciprocal of 1, which is still 1, and we get the negative of that, which is -1. And now that is the slope of our line M. Again, that's because M is perpendicular to L. So we attach that here, so y equals -x plus some unknown number. So notice that this is the slope-intercept form of our line M. We know the slope, that's -1, but we don't know the y-intercept. So we're gonna find the y-intercept. And the way we do that is we just, again, use any of our points here. And in this case, I'm gonna use B, the point B, because actually it doesn't go through A, it doesn't go through C. So point L doesn't go through, or rather, the line M does not go through point, well, the line M only goes through point B. Okay, so we don't have a choice. We have to use point B in here. So we're going to use the point B, which is 3, 0 there. So we're going to replace the x's with 4 because that's or rather B, because we're using B. We're going to replace the x's with 3. So we replace this with 3. We replace the y with 0 because that's 0 there. Now we can get y sub O. So negative 3 in here, you get 0. So we get y sub O equals 3. Now that we know that, we can replace this with that value. And we now know that the equation of the line M is this one. Okay, so we are now done with number 2, number 3, and now the fourth one here is asking us to find this area here. What do we know about this triangle here? We know that this is 90 degrees here because line L is perpendicular to line M. So we have a right triangle here. And how do we get the area of a right triangle? So we just need the sides. This side times this side times 1/2, and that's going to be the area of a right triangle. So we just have to find where they intersect. Okay, so we now get the intersection of line L and line M. And that's easy because we have the equations for line L and line M. So what we do here now is we solve the system of equations. So we have the equations. So this is the equation for line M, and this is the equation for line L. So we solve for X and Y where they intersect. And again, what we do here is the good old elimination trick. So you notice if we add both equations, we get 2y on the left side, and on the right side, we get x minus x, so that's 0. We get eliminate x, and then we get minus 3 plus 3, that's 2. And that's what we get here. 2y, so that's on the left side because y plus y plus y is 2y. And on the right side, you get 2. So y equals 1. Now that we have y equals 1, we can just substitute that either here or here. Okay, so again, just like the usual, I'm going to use this one because the numbers are smaller. So y equals 1. And if I replace that, then I get 1 equals x minus 1. So we move this minus 1 to the other side. We get x equals 2. And that's what we have here. So now we know that the intersection is 2, 1. So we know that the point V here is actually the point 2, 1. Okay, and actually, if you notice, it looks like it's an isosceles triangle, so shouldn't be a you can just divide it into 2 in here, right? Because this is 0 in here, or sorry, this is 1, 0, this is 3, 0. So right at the middle is actually 2, 0, right? 2, 0. And so because this is 2, 1, that means that we can actually draw an altitude here, and that's going to cut this triangle in 2. And you can get the area of the triangle on the right and the triangle on the left, and you can add them together or multiply it by 2, then you get the area of the entire triangle. But we're going to do here, or what we're going to do here is just get the length of this side and the length of this side. The length of this side here we can obtain by using the Pythagorean theorem. Okay, so we just subtract we get the difference in the x's, and then you square that. You add it to the difference in the y's, and then you add them together and you get a square root. So that's going to be like this. From A to V, so 2, 1, that's V. So 2, that's the x for V. 1 is the x for A. So 2 minus 1, you square that, plus this is the y for V, and this is the y for A. And then you square that again, you add them together, you get a square root, you get square root of 2. You do the same thing for the line segment BV. And you're supposed to get the same thing because like what we mentioned earlier, this is like an isosceles triangle. This is an isosceles triangle. So this side must be equal to this side, and this side must be, this side here must be half of the entire hypotenuse. And so you get square root of 2 for AV, you get square root of 2 for BV, and you use the formula for the area of a triangle. So you get 1/2 times AV times BV. So that's square root of 2 times square root of 2, you get 2. 1/2 of that is just 1. And so the area of the triangle here is actually just 1.